started. Hey there, welcome everyone once again to Astronomy Daily Live. So I hope everybody's doing well. It is 2 hours UTC on the 28th of February 2019. And if I'm paying attention correctly, that is, I believe that this is the last day of the month. So wow, yeah, it's already there. It's already here. It's already going to be March. Wow. Well, actually, one of my favorite days, my two favorite days of the whole year are coming up in March, and I will mention those momentarily. But I just noticed that Bobby popped onto the panel, so I want to say howdy to Bobby. Hey, what's going on over there?
Nothing much. Just checking it out. I forgot to plug up my microphone, so everything's all right now.
Sounds good. Looks good. Yeah. Looks great. Looks great. So I'm going to open up the chat here, see what's going on. Hey there, Jim. Nice to see you there. Earth Radio.
Sure. Yep, Ron from Earth. And I did. There's Uncle Bill Druin in the chat as well. If you look at the beginning.
Uncle Bill is being lurky. So good. He
lurky, tricky, pretty.
Yeah. He's one of these ninja dudes, right? Who has, like, well, what I imagine, at least, right? I have no idea if this is actually true or not, but he's got like 50 screens up, right? And he is moderating and monitoring all of these different things at the same time, and he's just so he is the internet ninja, and so he's just sort of hovering over us, right? Just sort of hovering over us, making sure that everyone is okay and there aren't too many shenanigans, right? We like shenanigans, but just as long as there aren't too many. So yeah, and I want to say hi to Tom in the chat as well. Glad to see you there. Excellent. Glad everybody's here. So yeah, last day of the month, and like I said, March has two of my favorite days of the year, right? One is well, I'll just ask you this: what day of the year is both a day and a command? There's only one. Have any idea?
Friday.
No. There's only one of these every single year. Good guess, though. Good guess. So it's both a date and a command, right? It's like you're making a command, right? You're telling somebody to do something. Tom got it. Yes, March 4th. March 4th. So yes, that.
What is so surprising about March 4th?
Because it's a command. March 4th, right? March 4th. You're marching forward. Some people get it, some people don't. That's all right.
Yeah. Okay.
And my my other favorite day in March, of course, is Pi Day, right? And Pi Day is really cool, right? And that, of course, is March 14th. It's 314. Right, so 314, which is a pretty close approximation to pi, and on that day, I always try. I don't always, but maybe I'll do it this year. I actually get get a pie, right? A pie, some kind of pie, and you know, thoroughly enjoy a pie on Pi Day, and you know, pi the mathematical value of pi is one of those what are called irrational numbers, and hello there, curious cannabis connoisseur. Nice to see you in the chat again. Welcome back. But so yeah, pi. You know, the value of pi, that number is one of these irrational numbers, as they're called. And yeah, I guess, Tom, I guess you're right. You could probably get away with a pizza pie too. So I think that would count. Yeah, yeah. You know, that's sort of like a vegetable pie, right? Or a meat pie. So yeah, I guess that counts. I always
in a meat pie.
Yeah,
but you can have it without the meat.
Well, you know, that is one of the perks of being a human, right? Is that we have choice, right? And you know, some things we can't choose, right? Which absolutely drives me crazy, right? There are certain things that we have to do, right? But there are certain things that we can choose to do or not do. And one of those things is what to eat and what not to eat. So I think that's awesome. I like to have as many choices as I possibly can, so I can choose, right? So I definitely like that. So yeah, pi, the one of the I don't know if this is true, but I can sort of imagine that it probably is. That there's probably an infinity of irrational numbers, and we know about a few of them, right? And these are numbers where when you look at, you know, the numbers after the decimal place, right? It just keeps going and going and going and doesn't repeat, right? So there's a lot of numbers that will repeat, you know, like 1/3, right? 1/3 is 0.33333333 and on, right? I don't think that that's necessarily called an irrational number. That probably has another term, right? But pi has this you know, interesting characteristic that you know, as far as we know, right? And I mean, I think we have calculated out to maybe a million decimal places of pi. I don't know how far out we've actually gone, but and you know, people have carefully examined the numerical pattern, you know, trying to find some kind of pattern, right? And there's no pattern, right? It's actually incredibly random, and it all stems from this weird notion that we have about circles, right? And what we found, right, is that the ratio between the diameter of a circle and its circumference is this value of pi, right? And pi of course is the Greek letter pi, pi, and you know, when you look at it, it doesn't seem to have an end, and it doesn't seem to have any kind of pattern at all. So you know, it is aptly named, right? An irrational number.
Yeah, kind of been funny what Curious Cannabis Connoisseur said said that maybe one day he might grow that giant beanstalk. Remember Jack and the Beanstalk?
Yeah, yeah.
Everybody
One
should
day
read
I
that.
want to find it. Yeah.
Yeah,
Well,
find that giant and steal the goose that lays the golden egg.
yeah, yeah. You got to be careful about those geese that lay those golden eggs, though. They, I don't know. I don't know. Yeah, those kinds of things are for people, not I. Not I. So yeah, pi is one of those irrational numbers. I think I
I
think
like the one with Mickey Mouse and stuff. You know, like when the giant stole the golden harp,
uh-huh.
and it was up to Mickey, Goofy, and Donald Duck to try to retrieve it and restore peace to the land.
Oh, okay. Oh,
I don't think you remember the Mickey Mouse version.
yeah, they something comes to mind there, but I don't I don't know if I've actually seen that or not. So,
So
the
you
other
see Jack and the Beanstalk, but not the Mickey Mouse version.
probably not. Yeah, I don't
Yeah,
know.
I'm not
Um,
sure if they're still around, if they're on YouTube and stuff, but you can
uh,
try it.
yeah, I'm sure they're probably somewhere
I know
somewhere
there
out
are
there.
lots and lots of Looney Tunes, so I'll be damned if you can find any Mickey Mouse or Donald Duck or something like that.
Yeah. Well, they want to protect all of those things, I suppose, and I don't know. Yeah, yeah,
And
not quite
maybe
sure.
Superman. I remember watching the original animated
Mm.
Superman from the 40s.
Okay, yeah, yeah. Animated. I remember a television show with with actual people. Probably not from the 40s though. Probably from like the 50s or the 60s or so. So yeah. Cheers. By the way, make sure that you grab your most favorite consumable of choice, whatever that might be. I once again have the hydrogen hydroxide here. It's a nice calming thing going on. So cheers to that.
Faucet water here.
Mm-hmm.
Cheers. Prost.
So
Cheers, Prost, and Ska.
yeah, excellent,
I think
excellent.
you learned that if you're a regular of the shortwave channel.
I guess I'm not that much of a regular. All right, well, cool. So yeah, one thing that I do want to alert all of you to is that Mercury right now is at its greatest eastern distance from the sun, right about now. So if you go out just a little tiny bit after sunset, and basically look west, right? It's going to be hard, because it's going to be sort of in the sunlight still, right? I think the maximum elongation is about 18 degrees, so it's still really close. Excuse me, to the sun. But if you go out at sunset, right, and then wait for it to get darker and darker and darker, and keep your eyes open, pretty low, right, pretty low to the western horizon, you will see a relatively bright star, right? And that object is not a star; it's a planet. It's planet Mercury. So if you haven't seen that yet, hey there, Atawahinta. How are ya? Nice to see you. Excellent. Glad you could stop by
lovely and
once again.
Untalanta.
Yeah, absolutely. I've got a great, or I should say, we have a great group of people here, right? I'm very, very blessed and very, very honored to be able to gather with you all as often as you possibly can, and yeah, I'm just absolutely blown away by the quality here. So yeah, well, and if it's cloudy, you've got at least a few days here of leeway left. Yeah, Mercury moves pretty fast, right? It has an 88-day orbit, right? So 44 of those days, it's sort of on the east side of the sun, and 44 of those days, it's on the west side of that sun. And most of the time, it's too close, right? So you usually have, um, you know, a good week and a half to 2 weeks that you can sort of see it when it's east of the sun or west of the sun. Of course, when it's west of the sun, you have to get up early in the morning in order to see it. But yeah, just I think I can be pretty sure in saying if you look west, pretty low, right? Maybe like 10 degrees above the horizon or so. Um, uh, Maybe 10 or 15 minutes after sunset, start looking, um, and basically anything bright over there you see, that is going to be it. And it's going to be low enough that it's probably going to be twinkling a little bit too. Usually planets
Now
don't.
they're in the chat. They're talking about the stellarium.
Yeah.
And about getting it from the app and then getting it from a different packaging managing system. They call it the flat pack. If you get if you're on Ubuntu, you might have to get the official PPA repository so that you can have the latest and greatest of Stellarium. I did the app method and I did the flat pack. Both of them actually gave me a precise location. Where the one directly from the main Ubuntu repository, they're must be like, oh, they're outdated, and I don't think you like that.
Cool. All right. Well, yeah, Stellarium or any of those sort of planetarium programs will definitely direct you to the.
And if you love Stellarium, you should try it on the off of the Android from the Google Play Store. I think it's about I think I paid either $2 and about $3. I think either $2.50 or $2.99 I paid for it, and I think that's a good deal.
That's a good deal. That's a good deal. I mean, of course, it's free for conventional computers, but $2.50, $3 for your smartphone. Yeah, that's a good deal. That's a good deal. Those, I mean, again, I say this over and over and over again, but it's like, there's an enormous amount of effort that goes into those things, so if you can, definitely make a contribution, right?
How much
if they're asking,
somebody would pay for Story Night Pro Plus?
I don't know. Maybe Atta can enlighten us on that. But I think I think that's I want to say it's a couple of $100, but I'm not. Don't quote me on that. I'm not exactly sure.
If that is so, it's mucho lunga.
Well, it's starting.
You want to know how much it is for a down converter so you can catch those satellite signals?
Huh.
$70K.
Oh, is that all?
Yep.
Let's get
Oh,
2 or 3.
100, I think 185 United States dollars, though.
Yeah,
So when you're
yeah.
dealing with an international audience, make sure you include like the abbreviations like 185 USD. And then maybe like people will use Google to convert it into probably what pound sterling, euros, pesos, whatever.
Yeah, yeah. Well,
Or even
that
Canadian dollars.
yeah, yeah. Well, yeah, if you want to clarify a little bit, that's all right. That's cool. We're easy here though, so we can make a few assumptions. But yeah, so anyway, if you haven't seen Mercury ever, now is a good time to do it. And you know, if you're so inclined, look at it through a telescope too, and you'll actually be able to see a little round ball, right? And that's it, right? Pretty featureless, right? Mercury is relatively featureless. So
You want to
so
know something, Nata? I can tell you how much a Jap for sure will be paying with Japanese yen. So I can spare a tab.
zillions and zillions and zillions.
Five.
Yeah, cool. But yeah, Starry Night Pro Plus. That's a nice program. Does lots and lots of things, right? So Bobby is feverishly working out the conversion rate between dollars and yen.
Okay. Okay, so a Japanese that would get in that program will have to pay 20,507 Japanese yen.
Okay.
Okay. Or I think if Tom is correct, so let me check on that. Okay, here we go. Yep, he's right.
He's right, huh? Wow, pretty good. We got confirmation. Excellent. It's always useful to get confirmation on your calculations. So yeah, cool. Well, anyway,
Now,
so hmm?
now let's see about Dominican pesos.
Okay.
Because on Let's Make a Deal, there was someone actually where like you can either get the big box, or you get the United States equivalent of so many pesos, and I forgot how many it was in $200.
Uh,
How much pesos are 200 American money. He ended up getting the box, and he won himself a motorbike.
oh, nice. All right. Well, cool.
So in Dominican pesos, you'd be paying 9,361 rounded.
Yeah.
And let's see.
That's all right. Let that through. Let it through. There we go. Cool. All right. Well, awesome. Yeah. So make sure if you've never seen Mercury, or just want to say hi. For me, I treat these things as friends, right? And so you definitely like to see your friends from time to time. I mean, I've seen Mercury zillions of times, right? But Mercury's a good friend. So I always try, uh, at these times to go out and give Mercury a wave and grab a few of those reflected photons. So yeah. In fact, let's where Mercury is relative to the Earth and the Sun here. I actually went over to heavensabove.com and pulled that up. So I might as well share that screen.
Yeah. I don't know where he got his map from, but according to Google, 200 United States dollars to Dominican pesos is actually 10,120 pesos.
Okay. Anyway, so here's the inner solar system, and you see here's the Sun and Mercury and Venus and Earth and Mars.
That was a host of Let's Make a Deal, so yeah.
Cool.
and do you know Wayne Brady?
No.
Okay, yeah, he's the host of that of the show of Let's Make a Deal.
Oh, okay, I see. Now this is interesting. See, I was actually looking. I was looking over here, Mercury elongation, and
if the planets are slowly drifting outwards, do you think Venus might maybe possibly be the next Earth?
Well, ooh, that's a toughie. I don't think that we know enough about how planets are moving around, right? We have this idea that things have been stable for a very, very, very long time, and I don't know about that. You know, there are some indications of some pretty crazy wandering. So yeah, not quite sure. You know, certainly if Venus were in a different location, at least in terms of distance from the Sun, things would probably change. You know, would it be like Earth? Ooh, I don't know. That's something I don't know that much about. Anyway, I was noticing here, see, these are the greatest elongations of Mercury this year, right? And so this is the first one of the year. And the elongation is 18.1 degrees.
I guess there's still a possibility we can catch that one.
Yeah, that's exactly what I'm talking about. Yeah. So, in fact, now is the time to do that, right? But then I noticed that the next one, look, is way out. It's like almost 10 degrees further out, right? And even the next evening one is like 7 degrees further out. So why? I was sort of wondering why is this one, this maximum greatest elongation, why is that so close as compared to this one and this one, or all the other ones? Why is this one the closest, right? Well, we've got our answer here. The orbit of Mercury is an ellipse, of course. See how the Sun here isn't in the center? That's because this isn't a perfect circle, right? And it just so happens that the greatest elongation from the Sun, as viewed from the Earth, is when Mercury is very, very close to perihelion, right? As close as it's going to get to the Sun. So naturally, the elongation isn't going to be all that much, right? Now, in 44 days, right, Mercury is going to be way over here, right? And Earth, let's see, in 44 days, that's about 1/10 of a year, a little bit more, right? So if there's half, there's a quarter, there's an eighth, there's a 10th, right? So in 44 days, the Earth is going to be maybe about here. In fact, you know what? We can cheat. Let's see, 44.
Steal and cheat just like Bieber Rasa Eddie Givendo.
You betcha. You betcha. I mean, I call it a cheat. It's not a cheat, really. Let's see. 44 days would put this around. Let's see. We're at the end of. Well, we're at the beginning of March, so 30 days there and 14. So let's say April 14th. April 14th. So let's update this. That should put Mercury about. Yeah. Okay. Wow, I was really close with that. That's pretty good. So as you can see, when Mercury is at its greatest western elongation, it's going to be near aphelion, which is when it's furthest from the sun. And so the elongation there, whoop, wrong one, is going to be.
Nobody wants to read your emails.
What's that?
Nobody wants to read your emails.
Nobody wants to read my emails. Definitely not. So yeah, it's almost 10-degree difference there. So that's pretty extraordinary, right? Now, actually, we could have actually looked and seen that it was April 11th is when that's happening. So let's put this April 11th instead. We can get sort of a little bit more exact. So there it is. There it is. And yeah, really, really close to aphelion for sure. So yeah, that's why this number is so small, because Mercury is at perihelion right about now. And that's why this number is so big, is because it's going to be at aphelion next time around. Of course, we're only going to be able to see this in the morning, right? If you're on the Earth looking at the sun, Mercury is to the right of the sun, which means it's to the west of the sun, which means it's in the morning. Venus is going to be over there too still, of course.
Yeah,
Mars
can you still see Mercury at sunup?
Right now, no. You can see it at sunset.
Okay.
Does that make sense? Am I?
I'm talking about like when the next that elongation happens and stuff.
Oh, I see. Yeah, I mean, it's going to be a little fainter, than what it is now. So exactly at sunrise, no, you probably won't, right? Because the sky will be way too bright. So you're going to have to, you'll see it, up until maybe like a half an hour or so before sunrise or so. And then, the sky will just get way too bright, to see it. So anyway, let's see. Let's go back to our current situation.
There's a such thing as a Venus elongation.
Mm-hmm. There are actually only two planets that sort of have this maximum elongation, right? And that's because they are closer to the sun than us, right? If you sort of imagine, if Mars was out here, right, it would be completely opposite the sun, and that's why it's called the opposition, right, which is 180 degrees from the sun, which I mean technically is sort of a maximum elongation, but they don't really call it that, right? So yeah, that this the fact we don't see Venus and Mercury 180 degrees from the sun is an indication that this model is probably correct, right? Probably. Seems to work pretty well, right?
How does heavens above get this data?
Well, all these things are calculated, right? We know the orbits of the planets really, really, really well. So yeah, it's just a calculation, right? I mean, it's a complicated one, but it's a doable thing. But it's just like how, you know, Stellarium does its calculations, you know, or how uh, and you calculate, you know, the positions of satellites going overhead, all of that. You know, if you know your location and you know your motion and you know the motion of the object you're looking at, you got it made, right? It's just a matter of some fancy math, and that's it. Yeah, that's it. Anyway, so yeah, make sure to go out and take a look at that if you can, if it's clear where you are. It's always a nice thing. So yeah, and just as another alert, probably tomorrow night it's going to be clear here, which probably means I'm going to be out with the scope. But I think, you know, we're getting into a time of year now where it's not really getting astronomically dark until about 7:30 p.m. Local time, which is right about now. So I don't mind doing the live stream in here like we normally do. I mean, I kind of prefer this. And then once I do the live stream, I'll go outside and do my observations, and you know, won't have to bother anybody with that. So maybe once in a while I'll do some more obs sessions, but I think those are going to be sort of limited to the winter time, because that's when these two things really overlap a lot. Now they're not quite so overlappy. So, you know, I don't mind uh, um, not being out there, you know, exactly when astronomical twilight ends, so I can, you know, be on the target, you know, and all that, right? I mean, if I'm a half hour late, I don't care about that. You know, one of the things that you definitely like to know about me is that I hate to hurry. I hate to rush. And if I have to rush, then I'd much rather just not do it at all, right? So
you are saying that there will be probably no live streams of obsessions, right?
not anything in the foreseeable future. I probably will, you know, just for fun, but you know, they're going to be sort of extras, right? You know, I'll do the live stream at the same time, right? And then you know, maybe once in a while, I'll just do a short live stream outside under the dark sky, because tomorrow it is supposed to be maybe even above freezing, right? It's going to be balmy. I'm going to have to, you know, be wearing, you know, my Bermuda shorts and stuff, because it's going to be so hot out that I'm not going to know what to do, right? So I think that'll be nice, and I think the humidity is supposed to be okay too. So we will see. We will see. All right, I'm gonna look at the chat really quick. Yep, it's all about doing the math. Yeah, you know, I'm curious. I thought about that, but you know, dates are dates. So you know, the greatest elongation was April 11th. I have to go with that. I have to. So, um, um, you know, curious. There is actually. Let me look. Let me look really quick. I've got it here. That your question about Mercury transiting the sun, which is what that's called, reminds me that I think Mercury this year is actually transiting the sun, but I don't remember when. So let me see if I can find that graphic. Here it is. So I'm going to make this big and aha, okay. I think, is it, oh, maybe not. Maybe not. Huh. I thought, oh, yes. There it is. There it is. Yeah, it's towards the end of the year, right here. I'll show you the graphic I'm looking at here. I'm going to share my screen again. I love sharing my screen and going to infinity. Look at that. Ooh. Where does it go? How far does it go back? I don't know. Man, that seems like a long way back there, though. I like it. Anyway, so here's a chart of the fields of view from two instruments on the SOHO spacecraft that are observing the sun. Right, there are two instruments that are called LASCO. I forget exactly what that stands for, but there's a wide field one, right, which is this whole thing here, and then there's a narrow field one here, right? And I'm going to zoom in a little bit.
Now, when is SOHO is going to be running out of gas and it's going to be the end of the edition?
You know, I'm not sure. SOHO has been going for a long time, and I think it's doing just fine. That's a good question, Bobby. I'm not quite sure. Not quite sure.
I think it was in the radiogram show, the shortwave radiogram show, but I forgot if it's going to be out of gas real soon or something.
We'll have to check that out, or maybe somebody in chat knows. But anyway, as you can see, do you see this thin pink line right here that says Mercury going this way? You see the arrow? It says November 8th to the 15th. So between the 8th and the 15th, it'll be going through here. And as you can see, this little dotted area here, right, is the disk of the sun, right? And as you can see, this pink line goes right, almost dead center, right? So we are going to have a transit by Mercury of the sun somewhere around what, 8 and 15 is 23. So somewhere around November 11th, November 12th or so. Let's actually go over here and see if we can find out any more details about that, because those are pretty rare and epic. They are epic. They are so cool to see. Yeah, November 11th. So let's see. Here's a visibility chart. So,
wow, another transit to Mercury. I thought the one in 2016 was the ones in the lifetime opportunity. I didn't know you could do it. You could have it again.
Mercury happens relatively often. Maybe you're thinking of the Venus one. Anyway, so find out where you are and see if you can see it. See, now, if you're in Australia or Eastern Asia, you ain't going to see it. You're not going to see it at all, right? If you're in Europe or Africa, you're going to see it, but you're not going to see the whole thing, right? You're going to see the first part, but the sun's going to set before you get to see it actually exit, right? If you're anywhere in this area, like South America, so, I know somebody in Brazil, so you are going to be able to see the whole thing, right, from beginning to end. And if you're in the eastern United States, you can sort of see looks like, Bobby, you're gonna be able to see the whole thing, right? I mean, the sun's gonna rise and Mercury is gonna happen. So when's this supposed to happen? Let's find out here. So so contact one is when it first touches the sun, right? This is this point right here. And that looks like it's going to happen at 12:35 UTC, right? So you have to do your conversion, right? For me, I'm 7 hours behind UTC. So, and remember, this is going to be in November. So if you have any kind of daylight time, I think November, everybody's on standard time, right? At least in the United States. Contact
Yeah.
two, yeah, contact two is when Mercury will be completely covering, totally inside of the disk of the sun. Greatest transit, of course, is when it's closest to the center. And yeah, wow, that's really, really close. That's super, super close. Contact three is when it just begins to move out, and contact four is when it actually stops touching the sun. So the whole event, you see, lasts like what, 5.5 hours? Is that
Okay,
right?
so daylight savings times will start here in the Western world. Will start at around March 10th and will end at November the 3rd.
Okay, okay. So you'll be on standard time again. So yeah, you'll just have to make the calculations. I'm in Arizona, where we don't observe daylight time. So I'm always on Mountain Standard Time, which means I am always seven
And I'm not
hours
sure what's
behind.
going on with Florida and stuff. I think they gotta have some type of approval or something, and that's the last time I ever
Oh,
heard about
okay.
it. Florida was proposing to be on daylight time all the time.
Oh, okay. Yeah, yeah. It doesn't really matter as long as everybody agrees and knows, right? It doesn't really matter at all, you know. Um,
I mean, UTC doesn't change, but the way you observe it will change.
yeah, of course, of course. Because in truth, there is only one time, and that's right now. That's it. Anyway, so yeah. Thank you for reminding me of this cannabis connoisseur, because yeah, this is several months away, but we are going to actually see a transit on November 11th. So mark your calendars, and
And you still
there.
got plenty of time to find a welding mech somewhere.
Yeah, and I mean, look, this is going to be all over the web, right? So I mean, if you're not able to see it, either because you don't want to or you can't, or because it's cloudy, doesn't matter, right? Now, I got to say, right, there's nothing like seeing this with your own eyes, right? So seeing it on a screen is okay, right? It's okay. But
I know, like during the solar eclipse, CNN was on top of it.
oh, sure, yeah, yeah, and that's fine. But there is nothing like actually seeing it for yourself. And what I do, right? I do something super, super simple, right? What I do is, they're over there. I take a pair of binoculars, right? And I set it up on a tripod, and I point the binoculars at the sun, and then I project the image of the sun onto a large white piece of
Like a
paper or
poster board?
cardboard or something, or yeah, like a poster board, right? And that way, lots of people can see it at the same time. And what you see, right, is the disk of the sun. And depending on how far away you put the poster board, you can change the size of the sun, right? So you can make it, um, um, like if you put it back 3 or 4 feet, you'll get a nice size solar disk, right? And then you'll actually be able to see this little black dot slowly moving right across the face of the sun, and it is epic, right? It's like I mean, it is literally out of this world, right? And it's really cool to see. So yeah, I definitely encourage you all to see that. So yeah, thanks for the reminder of that. That sort of jogged my memory that there was a transit. So excellent. And yeah, if you have a telescope, I'm reading the comments in chat. If you have a telescope, right, and like this or anything else, what you'll need to do is you'll need to get a filter, right, and and this is just my opinion, I guess. Do not get the kind of filters that go onto your eyepieces, right? Don't do that, because this telescope is going to focus that light right onto this eyepiece, right? And so if you're blasting your eyepiece and your filter with this sunlight, okay, you'll do okay, but this is going to get really hot, really hot. So what you should do instead, my suggestion at least, is to get yourself a filter that goes on to the front of the telescope here, right onto the front, right? Then you automatically block all that light right at the front, right at the beginning, right? Yeah. And then you don't have any problems with heat or anything like that at all. So, and then
you don't want to burn your eyes.
Yeah, we don't want to do that, right? Looking at the sun is not a good idea. Now, you can do it for very short periods of time, right? It's not going to do anything if you glance, right? But I don't recommend it because there's no point, right? There's really no point. So if you're going to use a telescope, the advantage of using a telescope, right, is that you can zoom in, you can magnify, right, and you can actually look at the actual little disk of Mercury, right? Which, I mean, look, it's going to look like a little black circle, right? That's all it's going to be. It's like a black dot.
Now, what kind of binoculars you can get to look at the sun, or like any filters that fits well with binoculars?
Well, with binoculars, those aren't really going to magnify enough to really be able to look at them, right? So if you can use any kind of binoculars at all and just do the projection thing, right? That is the safest way. And most people have some kind of pair of binoculars around, and those work really well. But yeah, solar filters are definitely available. The other thing that I would say, right, is if you really want to see this, right, find a local club that is doing an event, right, a solar viewing event that day, right? So if you're in the eastern United States, you're going to have to get up early in the morning, right, and get out there. If you're in South America, you're going to have all day, right? I mean, it's a 5.5 hour event. Um, when you're in Europe, you aren't going to be able to see the whole thing, but you'll see it in the evening, right? But yeah, that's another option, right? Is to find a local astro club and connect up with them, and they will have telescopes, right? So you don't have to buy anything at all. They will
And they
have
might want you to
everything.
pay an admission fee, right?
No, 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 no admission fees. No, I've never seen that. Nope, nope. That if they charge an admission fee, I would uh, yeah, I don't think that's going to happen at all. The amateur astronomers are way too enthusiastic. They want people to come out and see these things. So, local universities, if they have any kind of astronomy department or anything, they'll probably have an event too.
I
So,
wonder if
so
Fraser Kane would be like on top of it as well.
he
That would be
might,
great.
he might, yeah, yeah. And like I said, I mean, if nothing else, right? Get onto the internet, you'll be able to watch the whole thing. But it's not quite the same thing. So yeah, Atta's right. At least for star parties, right? I mean, for planetarium shows and for special shows and those kinds of things. Lots of planetariums, most planetariums do charge a fee, right? But for something like a public event, like an eclipse or a transit or anything, yeah, I mean, you'll be able to find a free event. And like I said, get yourself a tripod, um, get yourself a pair of binoculars. You just need one of the binocular sides, though, right? You don't need both. You just need a monocular, and set yourself up, with some poster board, and just have a ball. Yeah, absolutely. All right, cool.
Now, so let's find out when is the next meteor shower. I think it's going to be close around time for another meteor shower, huh?
Oh, there's always meteor showers, but Bobby, that's a good idea. There's a great site to do that. In fact, it's it's called the International Meteor. Oh no, I'm not remembering it. I think it's called the International Meteor Association, International Meteor Organization. There it is. Yeah, the International Meteor Organization, IMO, and I'll post the link here to that over in the chat because they've got an interesting page. Yeah, Atta is expressing exactly what I've always experienced. So yeah. Anyway, here's the International Meteor Organization, and I'm going to share my screen once again. Go to infinity. Woohoo! Wow. And then we're going to go over here. And what they've got is they have somewhere here, they've got, well, they have a meteor shower calendar. We can definitely look there, but I was hoping, well, let's start there. Let's just look because Bobby was asking about what meteor showers are going on next, and it sort of looks like, you know, there are meteor showers pretty much going on all the time, if you want to call it a shower, right? But it looks like the next major sort of named shower are the Lyrids, right? And those are going to be going between April 16th and April 28th. But let's see if we can get a better list, because you know, these are just sort of the common ones. Let's see if we can photographic, video observations, visual observations. I thought maybe I'm not looking in the right place. I thought that these folks had a visual meteor database. Is that what I'm looking for? Yeah, this is the one I'm looking for.
So where do you find the visual meteor database?
So that's under imo.net, and then you go to I think I went to observations and then here. Yeah, but this isn't what I was looking for either. What am I looking for? Visual observations. No, that's not what I'm looking for either. I hate it when I can't find exactly what I'm looking for. Visual meteor database, is that it? Live zenith hourly rate. I think that might be it. Yeah, okay. So we can choose which shower we want and actually look that way. But I guess we need to know what showers there are. So that's where we need to go back to here. Meteor shower calendar. And let's see if this has a full list instead of just a sort of a partial list here. Okay, so here's January to March. So the quantritids on the January 4th, January 12th to 15th. Let's see if, is there a table of any sort? It'd be nice if there was a table. Quantritids. So these are the gamma Ursa Minorids around January 18th. So that's, here's February 8th. I'll zoom in a little bit here.
So eventually the visual observations don't show you everything, which is sad.
Yeah. So it looks like right now and we can't really see these in the north, but the
and where you go to find a calendar?
This was a PDF file, so I went over to the meteor shower calendar, which is under resources, and then there's a PDF file here in your favorite language of choice, whichever one you prefer. So it sort of looks like there really aren't going to be any until April with the Lyrids.
Yeah.
And
so
that's,
I cannot believe that the calendar shows you the major ones, but not like all of them and stuff.
Yeah.
The major, well known.
Yeah, I think, you know, we can probably, I'll bet you that Google can be our friend here. Meteor showers 2019.
Because I like to try it when it's at peak and the radiant is up and stuff.
Yeah. Okay,
So I'm
yeah. So
guessing the radiant is in right ascension, right?
um, I'm not quite sure what you're. Oh, are you looking here?
Yeah, that's it.
Yeah. So yeah, actually, it's right ascension and declination, right? So
Okay.
1804. So 18 hours, 4 minutes in right ascension, and then positive 34 degrees in declination.
And what is
That's all.
CHR?
That is the zenith hourly rate. So that's a that's oh, I forget exactly what that means. Let's just look it up. So it's the number of shower meteors per hour one observer would see if the limiting magnitude is 6.5 and the radiant is straight overhead, right? So if you can't see things that faint, then your hourly rate is going to be less. And if your radiant isn't directly overhead, the hourly rate is going to be less. So what this is saying is that you know at best you can expect to see 18 per hour, right? So normally, if you see 18, you might see about half of those, right? So it's
I wonder
not.
if you can do a calendar search to eventually find out where's the radiant. And if I was out to find the radiant, okay,
Yeah, the
and
radiant doesn't really change. It just moves because the Earth is rotating and going around the sun. So
yeah,
so
but I'd like to have a graphical visual of the where the radiant's going to be at.
I think Stellarium shows those kinds of things. Pretty sure. So you might want to
Yeah.
look there. Make sure that option is turned on, because I'm pretty sure that the radiance of actually a lot of meteor showers are shown on Stellarium. Pretty sure. Pretty sure. So take a look there and see what you see.
Yeah. So the next major one's going to be the lyrics.
Yeah, yeah, and I mean, I guess if you want to call that a major one, right? 18 per
Chuck
hour.
Dagum, you're kind of like a bit super late. Live long and prosper.
Who's there?
Chuck Dagum.
Oh, Chuck. Hey, nice to see you anyway. You can come in anytime, even if you want to be late. um, these guys are a little bit more active, right? 40 per hour, 16 an hour, 5 an hour. Perseids are always high, right?
And they're usually at nighttime, right?
Well, it's always best to observe meteors after midnight, um, when the radiant is high, and the Earth starts to sort of spin into the shower, right? At least your side of the Earth starts to spin into the shower. So you just naturally see more. You can see um, um, any of these meteors from these showers any time of night, right? Any time of night, you'll be able to see them, but you're more likely to see them after midnight, just because of the geometry of the situation. Yeah. So cool. All right. Well, awesome. I think I'm looking at the time here, and I think it's about time to get on out of here for today. So yeah, excellent, excellent. I always like to um, keep on top of upcoming events, and I mean, for myself, right? I need to remind myself, you know, months in advance of things because yeah, I mean, you know, honestly, I'll completely forget about it, right? But so yeah, excellent. Yeah, you know, and that's another thing that that you don't need binoculars or a telescope for at all, is observing meteors, right? And observing satellites, right? Those are two things that you know, and you know, um, once again, you can sort of get into this and dive as deep as you want, right? I mean, if you just want to go out and look at them and get that rush, you know, of seeing a meteor, and that's all, that's great, right? But you can also, you know, count them. You can see where they're coming from, how fast they're going. You know, you can actually collect data on these things and report that data. Of course, it goes into a database, which can be used by scientists to you know, gain a better understanding of what is going on. You know, we don't really have a good idea about sort of the shapes of these clouds that the Earth moves through in order to create these meteor showers, right? We don't really have a good idea as to how they change, you know, their density with time. You know, are they flat? Are they round? Um, Nobody really knows, right? But if we collect data, you know, this observational data, and say, you know, this meteor was seen, you know, there at this time, moving in a certain way, blah, 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 right? Add that information to a database. Over time, you know, you accumulate lots and lots and lots of data, and you start beginning to see what is going on here, right? And you know, so that could be interesting, right? So yeah, you know, just like in most things, when it comes to astronomy, you can enter this field anywhere you want, right? If you just want to go out and look and have a fun time, that's awesome, right? That's absolutely fantastic, and that's enough, right? But when you want to dive into it, it's there, right? You know, the resources are there for you. Same thing goes with satellite observations, right? There are networks of people around the world who are tracking satellites, right? Because, you know, the motions of some satellites change, right? You know, because of, you know, defensive posturing, or you know, because, you know, they're trying to do a different kind of alignment, all of that. You know, there's lots of different reasons why satellites would move from, you know, sort of their normal courses. And there are organizations, right, who keep track of these things. And when they see, you know, that a satellite isn't exactly where it's supposed to be, they note it, they report it, and, you know, they change all the positions and stuff. And yeah, or you can just go out and take a look, right? And it's so cool, right, to go outside and just see a satellite passing over, right? Sometimes those satellites are things, you know, that you might know, like the Space Telescope, or, you know, the space station, all of that, and it's cool, right? It is very, very cool. So yeah, you know, those are at least a couple of things that it's all you need is your eyeballs and a moderately dark sky, right? I mean, the darker the better, but even right in the middle of the city, right, you can see the space station. No problem at all. It's super, super bright, right? The space telescope, yeah, you might be able to see that one too from the city. And when you get out where it's dark, like where I am, always dark, you can see, dozens and dozens of satellites every single day, right? It's absolutely amazing. So you don't need a telescope, you don't need binoculars, you don't need anything, right? Just go out and look. And of course, with the low Earth orbiting satellites, you can only see those maybe for an hour, hour and a half, or 2 hours after sunset
And we're about
or before.
to go off, James.
Yeah, I think I'm going to get out of here for now. So thanks everybody for coming in again. It's always great. I will be here once again tomorrow at 2 hours UTC. So feel free to come in anytime. Don't feel as though you have to come in each day. It's great if you do. I think it's awesome, right? I like to get together, with some good friends each and every day, shoot the breeze a little bit, talk astronomy and space and nerdy things, and it's fun. It's fun, and it's incredible that we can do this, right? Have a community here where we're not actually physically together, but in a certain sense we are. So I think it's great. So let's do this again. How about in a little less than 23 hours from now? I know that I'll be here, and I hope that you will too. And if not, check in on the next day or next week or next month, whatever you can, and spread the word around. Trying to build the community out a little bit. I'm not trying to get as many subscribers as I can and thousands of views and all this kind of stuff. I'm not interested in that. What I'm interested in is sharing the passion, right? I love astronomy, I love space and science and all that, and always have, always will, and I have a lot to share, right? Just the enthusiasm and the passion, right? I do not claim to know a lot. There's a few things I've sort of learned, but I like to have a lot of fun with this. So, all right, take care, everybody. I'm going to get out of here for now. Peace, cheers, and all that. I will see you on the spin. See you later. Bye.
Later.